Hey guys, welcome to the lecture series of Elementary Classical Mechanics, where we embark our journey from basic to advanced physics. This is lecture number 7, part 4 on multiplication in vectors. If you understand the previous video, then you know how to perform pretty much mathematical operations which I have taken in the previous lecture. Don't forget to check that out. In this lecture, I am going to take multiplication of vectors in the dot and cross product and example to understand it. The dot product is also called as scalar product because the output quantity is scalar quantity. Let us consider the two vector A and B with the angle theta in between them. We put a dot in between them to show that they are operating for a scalar product or dot product. When we find the product, this product is evaluated as magnitude of A multiplied by the magnitude of B of cos theta, where theta is the angle between the two vectors. The dot product can be understood when we have two vectors like this. One of the component is actually multiplied to get the product. They are also commutative in nature such that vector A dot vector B is vector B dot vector A. This product will always give the output in the form of scalar. One of the example is work done, which is force dot displacement. This is how we define work in physics, where force and displacement is a vector quantity and work is a scalar. Let us consider the two vectors A and B with their vector notion in 3 dimensions. Before going further on dot product procedure, the x cap is the unit vector. When you find the dot product of the vector along the same direction, you will get the angle between them as 0. So as per dot product, you can write the magnitude of x cap as 1 since it is unit in nature, and cos of 0, which will give x cap dot x cap as 1. Same goes when x cap dot y cap will give 0. Since the direction are now perpendicular to each other and cosine of 90 degrees is 0, thus you get 0. So you should be careful what are the angles between the two vectors when you are multiplying. And these are the rules for unit vectors. Now let us see how those two vectors can be multiplied. The vector A consists of ax in x direction plus ay in y direction and az in z direction. And similarly the vector B, when we find the dot product of these two, the dot product is only allowed for their own direction. For example, vector in x direction will multiply with x direction of the second vector, and similarly further on. The x dot and x dot, y dot and y dot, z dot and z dot will be 1, and finally we get ax bx plus ay by plus az bz. This is how we do dot product. If you didn't understand it, feel free to watch this video again. Let us solve an example to understand this. Find the angle between the two vectors A and B, where vector A is 3x cap plus 4y cap and vector B equals to negative of 2x cap plus 3 of z cap. We have the formula. Vector A dot vector B equals to magnitude of A and magnitude of B and cos of theta, the angle between them. We can find the magnitude of vector A and B as squaring. Adding and finding the square root of vector A and B, you can get magnitude of vector A and B equals to 5 and 3.6 respectively. Now we have remained with vector A dot vector B. Remember that only along the same direction the multiplication is possible, so from before we have derived as ax bx plus ay by plus az bz. We know that ax and bx is 3 and negative of 2 respectively from the given problem. Ay and by is 4 and 0 respectively, and az bz is 0 and 3 respectively. We put the respective values of a and b and vector a dot vector b we get after rearranging theta equals to cos inverse of negative of 6 divided by 18, and that will be 109 degrees. The angle between the vector A and B is 109 degrees, and that is how we use dot product in action. Cross product output is always the vector quantity, unlike the dot product where you will get the scalar quantity in the output. The operation of cross product is done such a way that for a vector A and vector B apart from each other by an angle theta, with the tail of them still intact is another vector C. This cross product is also equals to magnitude of A, B and sine of theta, the angle between the two vectors. Now first let us understand how the unit vectors behave in cross product. Let us consider the two unit vectors x cap and x cap, which are along the same direction, which makes their angle between them as 0. So applying the cross product formula, you get 0. Similarly, for the other y and z direction, unit vector will get the value as 0. But when the two vectors are perpendicular to each other, then what happens? You guessed it right. We will get the third unit vector perpendicular to the cross product of the unit vector. Similarly, you will get the rest of the cross product. Remember that the cross product is not commutative. So if we reverse the order of multiplication of the cross product, we will get the opposite sign in unit vector. The vector cross product is like a right hand rule. So consider a vector A multiplied in a counterclockwise direction of theta angle with vector B. You will get the vector C pointing upwards. Similarly, if a vector A is multiplied in a clockwise direction, you will get the negative of vector C, and that is downwards, and this is how the cross product works. Here I have two vectors A and B. When we apply the cross product is played out by using the determinant formula. If you are unaware of determinant, then please check my video on that. Now the arrangement of the cross product of vector A and B is such that all the unit vector at first row, then the vector A components in the second, and in the third row the B's vector components. Then determinant of that will be 3 by 3 matrix, and this is the form we get. This is how mathematically the cross product is done. And remember that cross product are not associative as I shown before in the demo. They are same magnitude but anti-parallel to each other. Now let us understand by an example. Find the vector product of vector A and vector B. They are given in the form of vector notation. Now we write it in the form of determinant. Now the missing will be 0 in that particular direction, and so the components will be 0 in the determinant form. Now we have this form x cap of determinant of negative of 4002, then negative of y cap as per the procedure of determinant, multiplied by the 2 by 2 matrix, the remaining one, and same for the third z cap. When we compute it, we get cap x of negative of 8, negative of 6 y cap, then plus negative of 8 z cap. And finally we get the product of vector A and B as negative of 8 in x direction, negative of 6 in y direction, and negative of 8 in z direction. Otherwise we can just take the negative common. This is how we do cross product. Hey, you made through the video. I hope you learned. So this is the end of the vector series, and next lecture will be on two-dimensional motion, and the first topic will be on projectile motion, I think. You can subscribe the channel so you won't miss out the learning. So see you in the week or two. Bye.